Lesson 111, transforming polynomial functions. So, I think that you guys know all of this. This is kind of like a review. So, we're going to do a table of what the transformation is that we're talking about, and then in function notation, what it would look like. So if we want to have a vertical translation, that just means up or down. We would take our function f of x and add k. If k is positive, you're moving up. If k is negative, it would be translation downward. If you want a horizontal translation, that's where you have the x minus k on the inside. So if it's a negative, if k is positive, it goes to the right. If k is negative, it goes to the left. And that's a confusing one, where if you see a minus sign, it's going to the right. If you see a positive sign, it's going to the left. Then we have what's called a vertical stretch. So it's getting taller and skinnier. You have some number times the function f of x, and the absolute value of a will be greater than 1. A vertical compression is a f of x for 0 is less than the absolute value of a is less than 1. That's when that's between 0 and 1. Then we have a horizontal stretch. Horizontal stretch is f of 1 over b times x for b, the absolute value of b greater than 1. And a horizontal compression is f of x, f of 1 over b times x for 0 is less than absolute value of b is less than 1. A reflection in the x-axis is negative f of x, and a reflection in the y-axis is f of negative x. So a couple of examples, if you had I don't even want to do these examples. Okay, but let's just look real quick. If f of x is x cubed plus 4, and g of x is f of x plus 9, graph g of x. So if you plug in f of x into g of x, you plug in f of x, then you got g of x equals x cubed plus 13. So we would just have a vertical translation where the, what do we call it? This y-intercept will be at 13. So it's just x cubed function translated up 13 units. And that's the end of the lesson.